All right, so in looking at this, okay, we have three types of solutions. We've already looked at them, so I'm going to show you a new way to look at this without doing so much work. If you want to sit there and solve the problem, that's perfectly fine, but I'm going to show you a shortcut. So this is a number outside of parentheses. We still need to distribute and combine like terms. Nothing changes about that. So I'm going to do my rainbow. And this is negative 2x, negative 2 times positive 3 equals negative 6. And then I'm going to bring down the other side of the equation. Do you see how I literally have the same equation? This is negative 2x, and I have negative 2x right here. I have a minus 6, I have a minus 6 right here. So because they are the same exact thing, that means infinitely many solutions. Okay, now let's look at one solution. See how they look very different? Both the numbers next to x are different. Both the constant terms are different. So because of that, that's why there's one solution. And again, you could solve these and tell me that x equals something, or the numbers don't equal each other, or the numbers do equal each other. But I don't even want you to do that if you don't need to. Okay? For this one, just like the first one, I can put things that are in the same tree together, and that gives me 3x plus 1 equals 5 plus 3x. Now, some people will be able to look at this and say, well, these are both 3x, but some people need it to be written the same. So if you were going to do that, you could write this, keep the first side the same, and then just basically switch these two, making sure that you keep the signs the same. A lot of times when y'all like to switch numbers, you like to move the signs as well, and we can't do that. We have to make sure that the signs stay on the correct number. So looking at this, do you see how the x's are the same number in front? That's good. But the numbers are different right here, which is why it is no solution. Okay? X's are the same, y's are different. So remember what we talked about before. Infinite solutions is both sides look the same. X's and constants. This one, neither x's or constants are the same. Okay? And this one is x's are the same, right? Those constants, those numbers are different. Okay? So infinitely, both sides look the exact same. One solution, neither side, neither the x's nor the y nor the constants are the same. The no solution, the x's are the same, but the constants are different. So if we look down here at this first one, first we have to do our barriers and combine our like terms. So if I draw my barrier, okay, I'm going to look at one side at a time. So in here, are there any things that are in the same trees? This and this are in the same tree. This and this are in the same tree. So that gives me negative 6 plus 3x. Does that make sense? X's together give me 3x. Negative 9 plus 3 is negative 6. So that's my left side. Then on the right side, I have a number outside of parentheses, so I need to distribute, do my rainbow. 3 times x is 3x. 3 times positive 2 is positive 6. So again, these don't look the exact same, and you would be able to tell from here, but we can change this. So I'm going to move my positive 3x to the front and move my negative 6 to the back. Now it's easier to compare. So, do both sides look completely different? Nope. Do they look the exact same? Nope. So my x's are the same, but my constants are different. That means that it is no solution. It is no solution. Okay? So, looking at the next one. I have a negative outside here, so we are going to distribute that negative. So I have negative times 3. Well, that's just negative 3. I have a negative times negative 6x. That gives me a positive 6x. That equals on the other side, positive 6x plus 5. Excuse me. Again, I can tell from here, but sometimes it helps to move things. So I'm going to move the 6x to the front and then put minus 3, and then that equals 6x plus 5. Do they look the exact same? No. Do they look completely different? Nope. So the x's are the same, the constants are not, which is just like the first one. No solution. No solution. Okay? For 3, draw my line. I can't do anything on the left side. All right, and then on the right side, I have negative 7 times a, negative 7a, negative 7 times negative 5, which is positive 35. We can move things around. Switch these two places. So bring out the sign that's on the 7a. Bring around the sign that's on the 35. And the other side I have no problems with. Do they look the exact same? Yeah, they do. So this is going to be infinite solutions. Infinite solutions. Okay? And not infantile. Bad. All right. So looking at the next one, I have my line. I have a number outside of parentheses, so I'm going to distribute. What's negative 3 times m? Negative 3m. What's negative 3 times 4? Negative 12. And then I just bring everything else to the other side. Okay? I have my m's out in front. I have my constants in the back. I'm fine with that. So, do they look the exact same? Do they look completely different? Or do they have x's that are the same but constants that are different? They look completely different. So this is going to be one solution. One solution. Okay? And then we are going to look at the last one at the bottom. I have a number outside of parentheses after I draw my barrier. I'm sorry. I have 4 times n. That's 4n. I have 4 times negative 8, which is positive 32. Equals. Oh, sorry. That's negative. I'm so sorry. 4n plus negative 32, which is negative 32 plus 4n on the other side. So let me rewrite this on the left side so that way it looks better. Okay? And then let's move this around. So the 4n will come up front with its positive sign. that minus 32 will go to